3.3. Graphing systems of linear inequalities. Example 1. Graph the system of inequalities. For example 1, first graph, x is greater than negative 3, remembering that you should have a vertical line at negative 3 and that your line should be dashed because it is not equal to. On the same coordinate plane, also graph y is less than or equal to 2. We will pause while you do this. If you've done it correctly, you should have a solid line at 2 and you should have shaded below. Your solution for systems of linear inequalities is the double shaded area. With your highlighter, go ahead and go over that area now so that it stands out. For example 2, we'll be graphing each of these equations. Before we do so, please write each equation in slope-intercept form. Subtract 2x, and you'll get 3y is less than negative 2x plus 6. After dividing each term by 3, you're left with y is less than negative 2/3 x plus 2. Your slope for this line is negative 2 over 3, and your y-intercept is 0, 2. Starting off at 0, 2, I'll go down 1, 2, and right 1, 2, 3. 1, 2, 1, 2, 3. This line will be dashed because it is not equal to. If you get ahead of me, go ahead and start the other equation. First writing it in slope-intercept form, and then graphing it. You may use my work as a guide if you need help. I've started at 2, 0, or 0, 2 at it, and then I've gone down 2 and right 1 because my slope was negative 2. This line is solid because it is equal to. Because this is y is less than, I will shade below the line. Again, go over your final answer with a highlighter. I'm using red so that it stands out. At this point, it might be wise to use your pen or a darker colored ink just to go over your line so that you can tell where your solution is. Check to see that your lines match my lines and that your shading matches my shading. The only difference between this system is that we have 4 different inequalities to graph instead of the 2 that we've just done. Graph each of these separately as we've done before. I'll show you this one, and you can do this one on your own. Subtracting x first from both sides, I'm left with negative y is greater than or equal to negative x. Dividing both sides by negative 1, we get y is now less than or equal to positive x. Don't forget that we switched the arrow because we've divided by a negative number. My slope, although you can't see it, is 1, and my y-intercept for this equation would be 0. Starting at 0, 0, I'll now go up 1, right 1, up 1, and right 1. Because this equation, inequality, is equal to, you will have a solid line. A good idea would be to use a marker or a Sharpie for your lines and a colored pencil for your shading. Because it's less than, I'll shade below. If you would please, go ahead and solve for y for the second equation and graph it on the same coordinate plane. Pause while you do that. Very good. We are now looking at this double shaded area. We'll graph the two remaining inequalities to figure out where the quadruple shaded area is. Starting with x is less than or equal to 3, we'll draw our vertical line, because it's just x, at 3. This line will also be solid because it is equal to. It's less than, so we will shade to the left, lightly. Trying to keep track of where your triple shaded area is. Your last inequality will be y is less than 2. For this one, we will have a horizontal line at 2, and it will be dashed because it's not equal to. Good idea to make it as thick as you can, because if you've noticed, we are getting somewhat of a hot mess. So because it's less than, we will now shade below the line. And you're looking for the area with 4 different colors. I would use my pen to make that a little bit more obvious for our eyes. Every coordinate in this quadruple colored area is a solution of this system. Be sure that your graph matches my graph. Let's go on. The babysitting club has a budget of $90 for a pizza party. Sounds important, so let's underline it. The club can get large pizzas for $10 and cases of soda for $3.50. The club would like to buy at least 5 large pizzas and at least 3 cases of soda. Write a system of linear equations, actually inequalities, that describes the given information. Use x for the number of large pizzas and y for the number of cases of soda that the club will buy. We've dealt with budget problems before in Chapter 2. If we know that the pizzas cost $10 and we're using x for the number of large pizzas, we can express that as 10 times x. Plus, we're also going to be spending $3.50 per case of soda. Consider now the budget expense. We have $90 to spend. So whatever we spend has to be less than, but can also be equal to $90. This is a system that we can graph in multiple ways. I will graph this by finding the x-intercept and the y-intercept. Remember that the x-intercept happens when y is 0, so you can cover up the y term, and what you're left with for your x-intercept is 10x is equal to 90, once the y part goes away. Solving by dividing both sides by 10, you find that your x-intercept is equal to 9. Do the same thing as a coordinate, which is 9, 0. Do the same thing for the y-intercept. Covering up the 10x, you're left with 3.5y is equal to 90. Dividing both sides by 3.5, y is about 25 if you were to round off. Looking at your graph, you do not have 25 lines on your y-axis, but you do have enough to go over for the 9s. I would recommend that you go by 3s for the y-axis. So about here, the 8th line would be 24, so just above it would be 25. For your y-intercept, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you can connect them. Because my amount has to be less than 90, I'm going to shade below that line. Some other information that we underlined was that we want to buy at least 5 large pizzas. At least 5 large pizzas. Knowing that we're using X for the number of large pizzas, and we want to buy at least 5 of them, my inequality will be X is greater than or equal to 5. This will be a horizontal line at 5. Just kidding, it's a vertical line at 5. And it is solid. I want the area that's greater than that, so I would shade to the right. The other inequality is for the number of cases of soda that we wish to buy. Knowing that we want to buy at least 3, this would give me y is greater than or equal to 3. Remembering that you went by 3s on your y-axis, it's going to be kind of low. This will also be a solid line here. And because you want it to be at least, that's greater than, you would shade above. The area you're now looking at is right here. So part B is now done. We have graphed the system. Part C gives 2 possible solutions for the number of large pizzas and the cases of sodas you can buy. There are multiple answers for part C. As long as you select a coordinate that's within this triangle, the triple shaded area, then you are correct. They're asking for 2. So if I know that this is 5 and this is 3, I know that I can use anything that has a 3, and I can use anything from this 3 minimum to this maximum. So I'm going to say 3 for one of my options. And my second option would be, just kidding, not 3, because that's before my line. 5, 4 would actually be okay. Another option would be 5, 6, 7 to the right, and then I can use 5, because I know it doesn't go over my line. Or 6, 7. Write 2 additional points or coordinates and check them with a partner or with someone else in the class. This now completes our lesson. Have a great day.